we will be doing solids of revolution, which is just using a curve and rotating about the x-axis in a full 360-degree motion to make a curve that looks like this. And in our example, we're going to be doing the semicircle, square root of 1 minus x squared, just to prove that in geometry we learned that the volume of a sphere is 4/3 pi r cubed, and we're going to prove that. So we will have the, I drew that wrong, hold on, the semicircle like this, the square root of 1 minus x squared. So when we rotate that, it will be 360 degrees around the x-axis, so it'll end up looking like a sphere. It'll be all the way around like that. We'll do this in a different color. Be all the way around like that, and like that. So it'll be like a sphere. Well, it will be a sphere. So, and this is only one across. The radius of this will be 1. So, in fact, when we have 4/3 pi r cubed, r is just 1, so 1 cubed. So we're looking for the disk formula to get us from here, the square root of 1 minus x squared, to 4/3 pi, because r cubed, when r equals 1, is just 1, because 1 cubed is 1. So, first of all, the disk formula is the volume equals pi times integral from a to b of the function of x squared dx, which is also saying the volume equals pi times integral from a to b of y squared. Same thing, times dx. So here in the semicircle, f of x equals the square root of 1 minus x squared, and we got lucky here. It squares the square root, so the square and the square root cancel out, and we're left with the volume equals pi times the integral from a to b, -1 to 1, because that is our diameter from -1 to 1. So we're going to go from -1 to 1, but since they are symmetrical on either side, they're gonna end up canceling out, because let's just say the volume of the top hemisphere will be 2. The bottom will be -2 if we take the integral of this, so it'll cancel out to 0. So instead of writing -1 to 1, we're going to change it to from 0 to 1, and then multiply it by 2. So 2 pi times the integral from 0 to 1. So we're just going to be taking 2 of the top halves, the top hemispheres, instead of the bottom and the top. So when we have the volume equals 2 pi times the integral from 0 to 1 of, we already said, the square root squared is just whatever the function is, so it will just be of 1 minus x squared. Because, in other words, when you put it to the power, the square root is to the 1/2 power, squared, so it's just be 2. 2 over 2 is just 1. Anything to the first power is just the same thing. So therefore, we can just take out power. We're left with 1 minus x squared dx. Do a basic antiderivative of this. We will get 1, and the derivative of y equals 1. Well, that's just x. And the antiderivative of -x squared is just -x cubed over 3. And this is from 0 to 1, like we said, or -1 to 1. And you'll see. I'll show you with -1 to 1. It'll just cancel out to 0. But x minus x cubed over 3, 1 minus 1 cubed is just 1, like I said before. 1 minus 1/3 You don't have to change 1 to 3/3. I mean, you can if you want. 3/3 minus 1/3 is just 2/3, but it should be easy enough that 1 minus 1/3 equals 2/3. And 0 minus 0 cubed over 3 is still just 0 minus 0, which is 0. So which is 0 equals 2/3. And this is all times 2 pi. Times 2 pi. Never factored that in. And look at that. When you multiply 2 pi times 2/3, you get 4/3 pi. So, would you look at that? And you have 4/3 pi, which was what we were looking for, because 4/3 pi r cubed is what it usually is, but r cubed is just 1. Because you're taking the sphere with radius 1. And I'll show you next to this. If we took it from -1 to 1, we'll take this part, or do it in a different color, and it's only this part, times 2 pi. So we'll have 2 pi times x minus x cubed over 3 from -1 to 1. So pretty sure it'll cancel out to 0, but we'll see. Probably will. Equals, change color again, 2 pi 1 minus 1 cubed over 3. We already found that out. It's 2/3 minus -1. -1 minus -1 cubed is still -1. -1 over 3 is just positive 1/3. So 1 plus, -1. So now we have hard to do in the head. So it's -1 plus 1/3. Because before we saw that -1 over 3, but it's negative -1 over 3. So it's just positive 1 over 3. -1 plus 1/3 is just -3 over 3, plus 1/3 is -2 over 3. So, as I have expected, it is 2 pi times 2/3 minus, this is -2/3. Wait, this is, alright, well, I might have gone wrong somewhere, but it should turn out to -2/3. -2/3, something like that. -1 plus, that should be about good. Yeah, well, whatever I did wrong, it's supposed to turn out to 0 like that, maybe. Whatever. 2 pi times 0 is still 0, and that's why whenever you see anything symmetrical like that, you should just go from 0 to 1 or whatever it is and just multiply by 2. So that's how we prove that a sphere of a circle is 4/3 pi r cubed.